So having a quick look inside the remote, we can see, let's start top right. So we have a big silver case that is going to be the resonator for the transmitting frequency. If we have a quick look at the data sheet, there we go, 433 megahertz resonator. And looking down, you can see the sort of the standard way of wiring it. So in the photo there, you can see right above it there is a 3-pin transistor package surrounded by capacitors and resistors, and that will probably be very close to the data sheet and how they've said to do it, all the various bypass capacitors and the way you feed the input to then transmit it effectively. And that's what our chipset at the bottom will do. So that little 8-pin package down there, which is an EV1527, I believe, if you have a look at the data sheet. There we go. OTP encoder using CMOS technology. It has 4 data pins. It has a 20-bit security code, but looks for unique identifier. And there we go. There's a pin out for it. So you have the oscillator coming from pin 1, then VCC, VSS. The transmitted signal comes out of it. So sorry, the signal ready for transmitting comes out of it. And then you have KO to K3, which will be your binary, effectively weighted input for your data. So by changing that configuration, you'll transmit something different. And down at the bottom, looks we have our sort of standard schematic of how to use it, which is interesting in itself. Something else that's quite interesting is how short this data sheet is. What's that, 3 pages? So, if you were somebody that wanted to design with this, it's very difficult to design with something where you've got so little information. If I show you, for example, a Infineon chipset, very similar, ASK FSK transmitter. It's a 10-pin package, it's slightly more complicated, but if you have a look at the datasheet, this is 41 pages. It goes into all the details. You get standard pin out, pin labeling, then you've got all the circuitry inside that it shows you how it all breaks down. It gets a block diagram of what's inside. It tells you all about the various oscillators, power amplification, power modes, etc., etc. The control circuitry inside. Power modes. It just goes on how it transmits, what the various codes are, etc. Circuit diagrams. This is the testing for it. Circuit diagrams, parts, bill of materials for testing, obviously. It just goes on and on and on and on and on, and it probably goes into circuit board layout and PCB design, etc. as well later on. But it goes for all the formulas and that, how to calculate the various aspects of how this chip runs and the various graphs and that. You can just see that this is so much more involved than the EV152 datasheet, which consists of 3 very minimal data sheets, which actually in reality, when you try and design with it, it's not particularly that useful. So there you go. That's the big difference between a cheap chip and an expensive chip, I suppose. So we know we have 4 data pins on it, which is the right hand side of the chip of the EV152. That then goes into effectively what is a data bus, we could call it. Let's call it a data bus, but it's 4 lines, 4 traces that go all around the board, feeding to various switches. So this is the interesting part. We have 12 switches, 4 data lines, so we know we need to do binary encoding here, and they've achieved that through using diodes effectively. And you can see the packages between the chipsets there, they're all dual package diodes, signal diodes. And by using diodes and the switches, you can actually create a very, very cheap encoder. So you create a binary encoder. It's not particularly sort of advanced. You could just say, well, you could use a microcontroller or something, but that's expensive when you could just use diodes to do the same job for you, which is what they've done. And if you look at that, it's interesting that all the switches that have a whole binary weight, so 1, 2, 4, and 8, have no diodes, and then all the others will have diodes on them because they're obviously activating several lines. And the problem is with this system is if you press more than one button at once, the potential of a dead short happens, which is the reason why you have the diodes. But interestingly, they haven't put any diodes on the main binary weightings. I would do that anyway, but they've obviously haven't done that. But what is also quite interesting about this is the bottom of the board where our 8-pin chipset sits, SMD chipset. We have an outline of another chipset, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have an 18-pin chipset there, which is intriguing because you think, well, what's that all about? Oh, to the right of that, you see the empty package. That's just for a switch, a power switch. If you look at the rear of the board, you can see where it just connects the power planes together, basically. Well, the ground plane to the ground terminal of the battery. So, but anyway, going back to this strange outline of another package in there. Well, I did a bit of quick searching online, and you'll find very easily that there is another cheap alternative for a transmitting chip called the PT2262, and this is, funny enough, an 18-pin package. You can see the wiring is not that much different. The pin layout is not that much different. So you have a few more data pins, effectively, which you can just ground out, and you have some address pins which you can also change. And if you look at the back of the module, the back of the circuit board, you can see they've actually got the pads running down the bottom there for the addresses. So you could solder between the pads to create the addresses for this chipset, and then they've just span out the traces to the data pins as well for that chipset. So this design could actually be used either with the 8-pin surface mount EV1527, or you can use the PT2262 in the 18-pin package and just drop it into the board and resolder it on there. And I suspect that plus on terminal there will be for obviously for a capacitor, which obviously the other chip requires. So it's interesting they've done that. They've actually designed like a system of redundancy, I suppose, in the fact that this circuit board can be used for numerous models. It can be used for a model that has a power switch. It can be used for the model that has the EV1527 as the main chipset. It can also be used to have the 18-pin PT2262 chipset if that's what you want to use on this device. And that actual flexibility is really used for not only different products, but it could be, for example, that maybe the EV1527 reaches legacy quicker than the other 18-pin package, so therefore they've designed it so you can use either, so that if one goes into legacy and stops being manufactured, they can just use the other chip. They're interchangeable. Maybe there's a supply issue. Maybe if there's a supply issue with one of those chips, they can always just swap to the other one and use that one. So that is a nice, neat piece of design, how they've managed to interface both chipsets onto the same board, effectively using the same similar footprint that the two chips use. So I like that. That's a good bit of design there. And you've got some other extra circuitry at the top there, which is all part of driving the antennae and that for the transmitting. So it's not much to it really.